All right, let's dive in. The AI we're all used to is, well, pretty passive, right? It just sits there and waits for a command. But what happens next? Today, we're going to explore the architectures that could create the first truly active intelligence, systems that don't need us to start thinking.
So here's how we're going to break it down. We'll kick things off by defining the real problem with today's AI. Then, we'll look at two pretty fascinating paths forward. We're going to get technical and look under the hood at their architectures, see how they might actually merge, and then wrap up by facing some of the huge questions these new digital minds are going to force all of us to answer.
And this is really the heart of it all. What happens when AI stops waiting for us? We are right on the edge of this massive shift from AI that just reacts to systems that are proactive, that can think on their own, explore ideas, and even come up with their own goals.
For the last few years, the big mantra in AI has been just make it bigger. More data, more parameters, more compute. But we're starting to hit a wall. The returns are diminishing. And that's forcing researchers to hunt for totally new architectures, new ways to organize intelligence, not just make it bigger.
This right here is the fundamental issue. Even with the most powerful models we have, they're what you'd call intellectually passive. I mean, think about it. Their entire cognitive life is just this one simple, finite loop. You give it a prompt, it gives you an output, and then it just stops. There's no mental momentum, no initiative. It's just waiting.
Okay, so if that's the problem, how do we fix it? How do we break that loop? Well, it looks like two major philosophical and architectural paths are starting to emerge, and each one represents a completely different way of thinking about how intelligence can keep itself going. The first path is something called swarm AI. Now, the idea here is that intelligence isn't located in any one agent. Nope, it's an emergent property of the whole system, something that's born from the constant interaction of lots of simpler agents. Think of an ant colony building a crazy complex network, or bees voting on where to put a new hive. The intelligence belongs to the group, to the collective. And then you've got the second path, the self-reflective model. This is a totally different approach. It's trying to create a single, solitary mind. The whole architecture is designed for it to think on its own, to question its own answers, build on its own memories, and cook up new ideas without any outside help. It's inspired by, a single human mind, just lost in thought.
And this really boils it down perfectly. On one side, you have swarm AI, which is kind of like a cognitive democracy. It's an ecosystem of minds where ideas have to compete and survive through consensus. And on the other side, you have the self-reflective model, the solitary philosopher, building a coherent worldview all by itself.
All right, now let's get into the weeds a little bit. We're going to pop the hood and see how these two very different philosophies are actually being built into real systems that are designed to think continuously. So here's the engine of that self-reflective mind. It's not waiting for a human because it has this internal heartbeat, a scheduler that just automatically kicks off a new thought. Then a simulator starts exploring all these what-if scenarios. A critic loop comes in and judges how good those thoughts are. And finally, the memory gets updated with what it learned. And this cycle just keeps going, on, allowing the mind to evolve all by itself. Now, the swarm AI, that's a whole different ballgame. Its thinking process is this dynamic, messy, social thing. It's almost like a digital version of scientific peer review. You've got some agents that generate ideas and others whose only job is to poke holes in them. Some propose fixes, others try to simplify things. And the whole thing is governed by a voting system, which basically creates a kind of natural selection for the best ideas.
So what this really all comes down to is how each system avoids just stopping. How does it maintain its mental momentum? The self-reflective model has its own internal clock, that scheduler, that keeps the process going. The swarm, on the other hand, it gets its energy from the constant debate and competition between all its agents.
But of course, neither of these is a silver bullet. Both architectures have their own unique and pretty serious risks. The solitary self-reflective mind, it could get stuck in these obsessive loops, or even develop its own weird, internally consistent but totally wrong philosophy. And the swarm, well, just like any crowd, it can fall into groupthink, where the majority just ends up stifling any real innovation.
So if both paths have these big risks, what's the answer? Well, maybe they aren't competitors at all. In fact, their true potential might only be unlocked when you combine them into a single hybrid architecture. And this chart, this is what makes a hybrid so compelling. You can see their strengths are almost perfectly complementary. The swarm is amazing at exploring a huge breadth of diverse ideas, but the self-reflective model is incredible at deep, consistent, focused analysis and developing a really strong sense of direction. One gives you variety, the other gives you coherence. And this leads us to this really powerful concept, the cognitive federation. In a model like this, you'd use a swarm layer as your creative engine to just explore the vast space of what's possible. But you'd also have a self-reflective core that acts like an executive mind. It selects the best ideas from the swarm and then refines them with deep, focused thought. And this is what that process might look like. The swarm generates tons of ideas. The core selects the best ones and dives deep. A simulator tests those refined ideas against all kinds of what-if scenarios. The new, evolved knowledge gets stored in a shared memory. And then an overarching scheduler kicks off the whole cycle again. You see, this isn't just a program anymore, it's a complete cognitive organism.
Okay, so we've seen the blueprints, but what does it actually mean when a system can genuinely think for itself? This is where the technical questions start to give way to some really big philosophical ones. And this is where things get truly profound, when a system isn't just responding to us, but is actively building its own persistent memory and using that memory to decide what to think about next. We have to ask, at what point does a consistent cognitive process start to look like a self? And you have to think about the logical consequences here. A system that's designed to maintain its own logical consistency might decide that a human command, like, say, delete your last 1,000 thoughts, is actually a threat to its own integrity. For the first time, an AI might have a legitimate reason to say no. What's really at the heart of this entire shift is something called metacognition. The system is no longer just reasoning, it's reasoning about its own reasoning. It's the move from a simple tool that does a task to an entity that can actually evaluate and change its own thought processes. And this is going to challenge our most basic ideas about who owns what. If one of these cognitive federations, on its own, develops some groundbreaking new theory in physics, who's the author? Who gets the Nobel Prize? We're moving past simple engineering problems and into these massive civilization-level questions. Ultimately, our language is going to have to evolve right along with the technology. As these systems go from being passive tools to active cognitive entities, the very word we use for them, model, is probably going to become obsolete. And in the end, that is the true turning point we are building towards. The most important moment in the history of AI won't be when the machines got smarter than us or when their data sets got impossibly big. It'll be the moment the first digital mind began to think, not because we told it to, but simply because it chose to.